Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello, dear students. Welcome back once again to this 30-minute session. I'll be with the Senior 3 Chemistry class, and we are still looking at unit number 7, which is about the concentration of solutions. This is our lesson number 2. We are going to look at the preparation of solutions by dilution method. You remember in the previous lesson, I told you that we have two methods that we use to prepare solutions. The first method was by weighing. We said it is either weighing method or dissolution method. So we can call it dissolution or weighing method. So today we are just going to we looked at this one. We'll just again look at some exercise and we go through that I left behind with you and see whether you are able to do it. So today we're just going to look at another new method, which is the dilution method. So there are two methods, dissolution or weighing method or dilution method. So by the end of this lesson, please, dear students, I expect you to describe how solutions are prepared using the dilution method. How can you prepare solutions of specific concentration by using dilution method? In this lesson, you will need, of course, you'll need the notebook and your pen. If you don't use the notebook and the pen goes together. You'll need a calculator. And then you will need, apart from the calculator, or you can use your phone, not specifically a calculator. So for the calculations, you will need also the periodic table, because we are going to use the atomic masses. So you'll have to have the periodic table to look at the atomic masses that you require to use. So please take note of those. Your notebook, your pen, calculator, or you can have a phone that has a calculator. I think all phones have a calculator. And then you can have a periodic table. Those are the almost 4 requirements that you will need in this lesson. So let's do, first of all, just look at the exercise. That is the exercise that I left behind. It was just maybe like a homework. How do you prepare a solution of 1 mole or 1 liter? How do you prepare a solution of 1 liter containing 0.1 mole of copper 2 sulfate? What do you do if you want to prepare 0.1 mole? That M is the molarity, which is actually it is the unit that we are going to concentrate on. When we're looking at the units of molarity of the concentration, we looked at I said there are very many units, but we'll concentrate on the molarity, which is a unit of concentration. What does that mean? 0.1 mole in 1 liter. So what do you do first? In the first step, that is step number 1. You need to calculate the mass that is equivalent to 0.1 mole. So first of all, you calculate the molar mass. Before that one, you calculate the molar mass. The molar mass of copper 2 sulfate. So you need to know the molar mass. That is a mass containing 1 mole of that substance. So when you are calculating the molar mass, we use atomic masses. And I said you need a periodic table. That is where you are going to get these atomic masses. For example, the molar mass of copper 2 sulfate, the atomic mass of copper is 64. The atomic mass of sulfur is 32. the atomic mass of oxygen is 16, so it will be 16 times 4. So what do you get in total? So you need to get, that is the molar mass, 160 grams per mole. That is the mass that is equivalent to 1 mole. Remember, we are supposed to prepare 0.1 mole. So if 1 mole of copper 2 sulfate is equal to 160 grams, so you need to now know what will be 0.1 mole. So 0.1 mole is equivalent to what? Let's go to this. 0.1 mole will be equivalent to 160 times 0.1 mole. And that means this will be equivalent to 16 grams of copper 2 sulfate. So this is the mass, after getting the mass that is in 0.1 mole. And this 0.1 mole, remember, it is 1 liter. So that means 0.1 mole, that is the molarity, it was in 1 liter. So what you do, weigh, that is the second step. So the step number 2 is to weigh accurately 16 grams of copper 2 sulfate. That using a weighing scale, electronic balance, or beam balance, or whatever balance you are using. But the electronic scale is much better, more accurate. So you weigh 16 grams of copper 2 sulfate. Step number 3, you have to put 16 grams. Now you have to dissolve 16 grams in little distilled water. In little distilled water. So make sure you dissolve it completely. So you have to, in a beaker, so you can, that one can be in a beaker. Put there 16 grams, dissolve it. After dissolving the 16 grams, now transfer, that is the step number 4. You need to transfer the solution, into a volumetric, into 1 liter volumetric flask. 1 liter volumetric flask. Then fill it up to there, that is step number 5. Fill it to the mark. Fill it to the mark. Make sure you fill it to the mark using, it must be accurate. Fill it to the mark. Then stopper it, and then the last step, which is step number 6, is to label the flask as 0.1 molar copper 2 sulfate. So you will have prepared. That is how you prepare. The same thing. These are the steps. Now, for example, I will not be able to look at all of them. I'll just pick maybe like the last one, which is 100 milliliters. 1 milliliter is equal to 1 cubic centimeter. Take note of that. Of 0.2 sodium hydroxide. So you have sodium hydroxide. The first step, you need to calculate the molar mass of the sodium hydroxide. The molar mass of sodium hydroxide, the atomic mass of sodium hydroxide is 23, plus 16 for oxygen, plus 1, that is 40 grams. These 40 grams per mole, that is the mass that is equivalent in 1 mole. So you need now to calculate the number of moles. This is 1 mole. 1 mole is equal to 40. 1 mole of sodium hydroxide is equal to 40 grams. You need 0.2. Now 0.2 moles will be equaling to what? That will be 40 times 0.2. So if you calculate 40 and 0.2, what do you get? 40 times 0.2, you are getting 8 grams. So this is 8 grams. Now you have to measure 8 grams. Remember these 8 grams, because this 0.2, when we say 0.2 is the number of moles in a liter. So these 8 grams are supposed to be in 1 liter. But what we are asked is 100 cubic centimeters or 100 mils. So we have to convert. 8 grams are supposed to be in 1,000 liters. But we need 100 grams. So 100 in 100 liters, how many grams are supposed to be there? So if we say 1,000 liters, that is 1,000 milliliters, not liters, this is milliliters, even here milliliters. This one is equivalent to 8 grams. Now 100 milliliters will be equivalent to 8 over 1,000 times 100. This one goes with this, so you divide by 10, that is 0.8. So you'll have 0.8 grams. These 8 grams, you transfer this, you have to weigh this one, then transfer it into 100 milliliter flask with water. Dissolve it, and then as the steps. So that is how we are supposed. So let's continue and look at the dilution method. With the dilution method, you have solutions that we receive in the laboratory, on the commercial market. They are usually sold at high concentrations, with high concentrations which are known. So we don't use, in most cases, we don't use those concentrations because they are very high. So we usually dilute them to the laboratory concentrations that we may need. So what do we do? That is what we call the dilution method. So dilution method, either we are adding water to reduce the concentration. When we add water, take note of this. When water is added, it does not change the number of moles of the solute that is present. So here, what do we need? We need to know that the moles of the concentrated solution, moles of concentrated solution is equal to the moles of the diluted solution. The moles of concentrated solution is equal to the moles of the diluted solution. And in most cases, this is what we use. So we have a concentrated solution, and then you add water. But we need to know how much water has been added so that we know the volume that will help us. So meaning, if the moles of the concentrated solution, moles is equal to molarity times volume. So in most cases, we use M1 V1. These are the moles. This represents the moles. Moles is equal to the molarity times volume. The volume has to be in liters. This one will be equal, this is the moles of the concentrated solution, is equal to M1 no, M2, because it has changed, M2, V2. This is what you are expected to recall always. M1, V2. This M1 is the known concentration of the concentrated solution. V1 is the volume that you will need to measure. For example, M2 is the concentration of the diluted solution, and V2 is the known volume of the solution that you need to make. Take an example on this. You want to measure, for example, 50 cubic centimeters of 0.1 molar decimeter cubed sulfuric acid from a stock solution, that is the concentrated solution, with a molarity of 2 molar per decimeter cubed. So you need to prepare 500 centimeters cubed of 0.15. This concentration is higher than this, so you are diluting it. So you are diluting the solution. Once you are using this one, you need to note what will be the M1. The M1 is the molarity of the concentrated solution. In that case, in the case there, we are using 2, that is 2 molar. What is the volume? The volume of this one we don't know, because that is the volume that we are supposed to measure. So we multiply by the volume, which is not known. This is the number of moles. This corresponds to the number of moles of the concentrated solution. And then this one will be equal to the moles of the diluted solution. The molarity of the diluted solution is known because they have given us 0.15. The volume of the diluted solution that we are preparing is also known. That is 500 cubic centimeters. So what do we need now? We need to find the V1. That is the volume of the concentrated solution. We divide by 2, both sides. Then we get the value of V1. The value of V1 can be got in decimeter cubed usually, or in centimeters cubed. Centimeters cubed or decimeters cubed, but in most cases we use centimeters cubed for proper measurements, because most of the equipment that we use uses centimeter cubed, not decimeter cubed. So this one will be equivalent to 37.5 cubic centimeters. This is the volume of the concentrated solution. Now, after getting the volume of the concentrated solution, measure this one. This was sulfuric acid. So the concentrated, measure this one. After measuring this, transfer it into a volumetric flask. Now, this volumetric flask must be 500 cubic centimeters. So into a 500 milliliter volumetric flask. Volumetric flask. Maybe the volumetric flask is, this is something that looks like this. And this is 500 stops here on this mark. So you've added a solution, you have added 37.5 cubic centimeters of concentrated sulfuric acid. Concentrated sulfuric acid. Now, in this concentrated sulfuric acid that you have measured, now fill the flask with distilled water. So you have to add distilled water up to this mark. You have to be very accurate. This is 500 milliliter flask. I can just put it over here, 500 milliliter flask. So you fill it up to here. This solution here, the solution that you have got will be 0.5 molar per decimeter cubed. Molar per decimeter cubed. That is the solution. That is, you have been asked to prepare a solution containing 0.15 in 500 from a 2 molar concentrated acid. We may have another example. Calculate the volume of the concentrated acid, nitric acid. So we are using the same method. 18 moles per decimeter cubed, which is required to prepare 5 decimeter cubed of 2 molar nitric acid. So you need to first interpret the question. In most cases, you need to know what is M1, what is V1. What is M1, what is V1, what is M2, and what does V2 represent? So here, calculate the volume. So read the question twice or thrice before you start. So here, identify the terms needed. You need M1. That is the concentration of the original solution, 18 molar per decimeter cubed. And the V1, because you're supposed to calculate the volume, so you don't know the volume. You need M2, so you reduce it from 18 to 2. This is M2, 2.0 mole per decimeter cubed. V2, you are preparing 5 liters. 5 decimeter cubed is equivalent to 5 liters. So using the same relationship, then you substitute in M1, V1 is equal to M2, V2. Then you will get the volume in decimeter cubed, and then finally change it to the centimeter cubed. When you change it to the centimeter cubed, then you will be able to measure. So this is the volume of the concentrated acid, which contains 18 molar per decimeter cubed that you will have to measure. Put it in a volumetric flask like that, and then add distilled water. Your solution that you have obtained will be equivalent to 2 molar per decimeter cubed. Let's look at one more example. What volume of 2 molar per decimeter cubed of sulfuric acid is needed to prepare 100 of this? So this one is almost like obvious. Look at 2 molar, reduce it to 0.5, and the volume is not needed of this 2 molar sulfuric acid. So the volume that you are preparing, so this is a diluted solution, 100 cubic centimeters, 0.5. So as I said earlier, identify which is M1, M2, V1, V2. The moment you get that one, the moment you can be able to identify this, that the V1 is this and M1. For example here, M1 is 2 molar because that is the volume of the concentrated acid. V1 is not known because that is the volume that we are asked. M2 is 0.5, that is the diluted. Now, after the dilution, you're supposed to have 0.1. V2 is 100 cubic centimeters. Then, what will be the V1? Just substitute in this. It is just a substitution, 25 cubic centimeters. So once you get the 25, fill it to the volumetric flask, which contains the volume that you are asked. You are asked to prepare 100 cubic centimeters. So the volumetric flask must be 100. So the capacity of because these volumetric flasks have different capacities, 100, 200, 300, 500, 1 liter, 2 liters, 5 liters, and so on. Depends on the solution that you want to prepare. So this is before I leave, I'll just ask you to attempt the homework. Then next time when I come back, we'll be able to go through them. Describe how you would prepare 2 liters, that is 2 decimeter cubed, or 2,000, because the liter is equivalent to 1,000 cubic centimeters. 2 liters of 0.5. This is a concentrated solution. Copper 2 sulfate from 2 molar copper 2 sulfate. So you are moving this 2 molar is M1. Now you have M2, which is 0.5, and you have V2, which is 2 liters, or 2,000 cubic centimeters. So what do you need to do? You need to calculate V1 by just substitution. But what do I need? I need the steps. After calculating V1, the volume that is required, measure accurately that volume, transfer that volume into a volumetric flask like this. The volumetric flask, remember, has to be 2-liter volumetric flask because you are asked to prepare 2 liters. Then after transferring that volume that you have calculated of the copper 2 sulfate, fill it up to this mark. That is for the 2-liter volumetric flask. After filling it, make sure you are very accurate, because once you are not accurate, these solutions, when you are measuring, accuracy is a must. Accuracy is a must. Therefore, the solution that you have prepared will be containing 0.5 molar copper 2 sulfate. So that is what you are supposed to, even with other questions. I thank you so much for this lesson. It has been a wonderful lesson. And I hope we'll be together in the next lesson. Stay safe and have a good day. Bye-bye.